Hi, in this video, contents related to impact of environmental factors on UAV performance will be shared. Unmanned air vehicles are sensitive systems that can experience performance changes due to direct effects from weather conditions. To ensure UAVs operate safely and efficiently, it is essential to analyze environmental conditions thoroughly. Factors such as air temperature, pressure, density, humidity, and altitude affects UAV flight duration. Temperature, humidity, wind, altitude, precipitation, dust, electromagnetic interference, and lighting can directly impact the UAV's electronic components, batteries, motors, and sensors. For example, very high and very low temperatures can shorten the battery life, while strong wind can disrupt the flight stability. This video will provide a detailed examination of environmental factors affecting the UAVs and practical advice on mitigating these effects. Extremely cold weather can negatively impact drone performance. This can lead to reduced battery information and shorter flight times. Extreme cold can affect electronic circuits, increasing the probability of moisture condensation and making plastic parts more brittle. In such conditions, using LiPo battery heaters, storing batteries at room temperature, and ensuring the temperature adjustment can be beneficial. Additionally, using winter-grade protective lubricants for moving parts is recommended. Extremely heat can cause motors and electronic speed controllers to overheat, reduce lift due to lower air density, and cause the battery to discharge more quickly. In this case, it is necessary to avoid direct sunlight before and during flights. Propeller guards can use it to improve the airflow around the motors. Planning flights during the cooler times of day, shortening the flight durations, increasing the waiting times between flights are measures that can be taken for flying in hot weather. Thermal activity affects the UAV stability due to vertical air movements caused by temperature changes, with challenging navigation accuracy. Urban environments, building turbulence, street canyon winds, and heat island effects can impact UAV stability. Terrain-induced wind changes, especially in mountain areas with wave effects, coastal regions with complex wind gradients, and valley with wind funneling characteristic, require careful attention when flying nearby. In desert flights, operators should ensure that temperature do not reach levels that could damage electronic system. To protect against sand and dust, operator can use special seals, filters, protective enclosures to prevent particle ingress. In coastal areas, salt spray poses significant risks to drone equipment, accelerating metal corrosion and endangering electronic components. Technicians should apply protective coatings, use corrosion-resistant materials, and implement corrosion-preventing techniques to mitigate environmental degradation. Humidity, moisture can use short circuits in electrical components, corrosion in metal parts, and fogging on camera lenses. To prevent these effects, it is recommended to use silica gel packaged in storage containers for drones and batteries. Additionally, applying the protective coatings to circuit boards provides long-term protective in humid conditions. Proper drying procedure should be followed, and anti-fog measures should be applied in camera lenses. Strong winds can lead to excessive power consumption to maintain drone position. Unexpected deviations may occur while drones is hovering or performing waypoint missions, and maximum flight speed may decrease when flying against the wind. To prevent these situations, check wind speed and direction before the flight. Adjust the flight routes according to wind and increase the battery margins for return to home function. Sudden gusts can cause abrupt altitudes or position changes, loss of control and structural stress on drone. It is advisable to avoid flying in such conditions using wind forecast application to predict wind in advance and flying safer conditions. At high altitudes, air density decreases, reducing lift and motor efficiency. Additionally, overheating may occur due to less efficient cooling. When flying at high altitudes, it's important to adjust the propeller pitch. If possible, use high altitude propellers, reduce payload capacity, and consider the reduced flight duration and performance. Now, let's discuss the effects of rainy weather conditions on drone performance and precautions to take. Rain can cause short circuits in electronic circuits, reduce camera visibility, and increase weight due to water accumulation. Therefore, drones with appropriate ingress protection ratings should be used. Hydrophobic coatings should be applied to camera lenses, and flights in heavy rain should be avoided. Snow can reduce visibility, cause ice deformation on propellers, and lead to incorrect readings from ultrasonic sensor. In this case, propeller de-icing system should be tested, waterproofing should be ensured, and attention should be paid to GPS signals. Dust particles can cause wear on moving parts, clog cooling vents, and reduce camera image quality in dusty environment. Propeller guards should be used. The drone should be thoroughly cleaned after flight. Dust filters should be placed on intake vents, and cleaning kits should be used for camera lenses. Ingress protection is an international standards rating that indicates a drone level protection against dust and water. The IP rating system consists of two digits. First digit is 0 to 6, indicate the level of protection against dust, and second digit 0 to 9 indicates the level of protection against water. For example, 54 means partial protection against dust and resistant to splashing water. IP55 means particle protection against dust and resistance to water jets from any direction. IP67 means dust protection and water resistance up to 1 meter depth for 30 minutes. IP68 means full dust protection and long-term operation in water deeper than 1 meter. Underwater drones carry the IP68 label. The electromagnetic interference can originate from very voltage power lines, radio towers, base stations, and industrial equipment. Electromagnetic interference can cause a GPS signal loss, image interference, or signal loss, control signal interferences, and compass errors. To avoid such effects, it is beneficial to maintain line of sight operation. Use frequency hopping spectrum control for wireless communication. Calibrate the compass away from EME sources. For more precise real-time kinematics GPS, EMI shielding is a technique used to protect electromagnetic devices from electromagnetic interference. EMI shielding materials such as metal enclosure or conductive coatings act as barrier to block the absorb these waves, preventing them from reaching the drone's internal circuit. Low light conditions are another environmental challenge. Camera performance may decrease and UAV operators may experience orientation issues. To overcome these, drones with low light camera features should prefer LED lights should be attached to the UAV to increase the visibility, and flights with drones locking appropriate equipment should be conducted before sunrise and after sunset. Bright sunlight can cause overexposure in camera images. In this case, using neutral density filters will be beneficial. Bright sunlight can also make difficult to see control screens. Using sunshades for control screens is important. Additionally, when planning flights, it is advisable not to schedule flights at noon unless unnecessary. Following some practical advice can help reduce environmental impacts of UAV. For example, always check weather forecasts before flights. Using mobile weather station to obtain accurate on-site data is beneficial. Additionally, conducting a comprehensive environmental assessment before flight minimizes potential risks. Keeping a record of environmental conditions for each flight will provide a reference for future operations. Finally, regularly reviewing environmental operating limits for each drone models and flying in suitable environmental condition is important. In this section, we covered the impact of environmental factors on UAV performance. I hope the contents have been helpful. See you in next content. Goodbye.